Oops, sorry. All right, can you guys hear me? Excellent connection. Okay. Yeah, the proof of the kosher rule. Yes, you have to know it. I've got the worksheet here on tangent equations. Does anyone need that first? Else, I can go through questions from the supplementary book or the class textbook. Up to you guys. I am ready. Yep. 102 number 6. Okay, page 102. 1026M. Supplementary. Okay, this is 1026M from supplementary. So what do they want here? Just the derivative? Differentiate. Okay, so for this one here, they want dy dt. So to take the derivative of this one here, product rule first. Hello. So enter the product rule. This will be to the third power. This will be 19. So when you go ahead and take the derivative of this, you do the power rule. So you drop down the 20, subtract 1. Derivative of the inside kicks in here. So we're using our chain rule. So when I take the derivative of the inside, you're going to have to take the derivative of this expression now. So the derivative of t is 1. But then here the power rule kicks in again. You drop down the third. Subtract 1, you get minus 2/3. But now you have to take the derivative of the inside of this expression now, to which you'd multiply by 1 plus 2t. And then you can close this down. So I don't know how far they went with this, but that would be the derivative. I don't know if they simplified it any further. But that's the derivative for 6m. Someone asked 103 number 9 from the supplementary. So there's a ton of these questions, this style of problem here. They want you to find, for number 9, they want you to find f prime at 2. So f prime at 2 here. Aeon, would I ask for 1026m to be simplified? No, there's not really much to do with it, like in terms of simplifying it. I'd probably, for something like this, have you evaluate it at like 1 or something, like at a number 0, 1 or whatever. But for this one here, they want capital F prime at x. This will be f prime at g at x times g prime at x. And they want this evaluated f prime at 2. So this will be f prime at g at 2 times g prime at 2. And if you look at number 9, did they give us all this? I know that g at 2, this is given to me, g at 2 is 4. And g prime at 2 is 3. And then f prime at 4, they gave us is 5. So this becomes 5 times 3, you get 15. Okay, so there's, hey, volts. I'll do the class textbook questions after. Chetyan, I don't know the page number, so I can't really do this. Oh, Bansari writes it right in there. How would you simplify? Sorry, Bansari, what? I had to edit it up. I couldn't see what you were typing. How would you simplify the root of x? Bansari, do you mean this? Oh, sure. I don't know. Bottom derivative the top. I would do quotient rule, so bottom derivative the top minus the top, and then the derivative of the bottom is 2x, all over the bottom squared. So that's your derivative. So, sorry. So I'm getting here f prime at x is equal to, just leave it like this, x to the minus 1/2, right? X squared plus 1. This would be minus x to the 3/2 now if I put this together. And this is x squared plus 1 squared. So that would be the first step, is take your derivative using the quotient rule. I would do the quotient rule, and then that's all I did. And I kind of pushed the thing in the front here, the minus exponent in the front. I would just multiply top and bottom by 2 root x. So if you multiply the top and bottom by 2 root x, you get f prime at x, right? You're going to have to distribute that. You're going to get f prime at x is just x squared plus 1 minus 4. And this here, Bansari, when I take the root of x times x to the third, you're going to end up getting x squared. So it comes out quite nice, and you get 2 root x squared plus 1 squared. You guys see this? So f prime at x is minus 3x squared plus 1 over 2 root x times x squared plus 1 squared. You can leave it like that. Hello, Ellen. You can leave it like that, or you can factor the minus sign out. Like, you probably should factor the minus sign out. It's not a big deal, but I would guess that they might do that when they like fully factor this thing for your first derivative. And sorry, is that good? Perfect, thank you. Nice. Okay. All right, I've kind of lost track of all the questions, so if I miss your question, just ask again. It's not a big deal. Eric wants me to do number 6 from the finding equations tangent worksheet. Sure. And then Chatyana's, oh, okay, page 111, number 6. I'll do that, because I'm on the supplementary. 111, number 6. One 111, number 6. Didn't we do this one like today? I did this today. Oh, sure. Okay, sorry, Chuck. Yeah, I didn't read your full message. Okay, so with this one here, the challenge with this one was for the value of n. Like if n is 1, they want you to find a general pattern. If f at x is x, what's the first derivative? Well, the first derivative of this is just 1. And then if n is 2, it's a different function. The function changes, becomes x squared. So now they want you to find a formula for the second derivative. Well, to find that, how would I go about finding that? I know the first derivative would be 2x, so the second derivative would be 2 times 1, also known as 2 factorial. If n is 3, then f at x is x cubed, and in which case they want me to find a formula for the third derivative. Now, so the number of times you take the derivative is going to change, so therefore f at x is x cubed. The first derivative is going to be 3x squared. The second derivative is going to be 3 times 2 times x. And the very last derivative, you're going to get 3 times 2 times 1, which is exactly 3 factorial. Right, 2 factorial, 3 factorial. And then you can kind of see, like, if I chose the fourth derivative, you can probably see that the fourth thing would be 4 factorial. So the general pattern was the nth derivative would be n factorial of your function f at x would be x to the n. So that's the the general idea. Does that make sense, Chatyana? You were asking that? Hey, Arj, how are you? Okay, I'll go to Aeon's question. He wants number 4 from page 111, and then I'll get to page 4 from 111. Or sorry, page 111, number 4. So for this one here, they want f at x is the square root of 1 plus x squared, or 1 plus x cubed, and they want your derivative. So you take your first derivative, as you would expect. I took my first derivative, and the issue with this one, Aeon, is you have to clean it up a bit. I kind of put everything together. There's my first derivative, but I want to evaluate, the question's asking to find f double prime at 2. So you have to take the second derivative of this, but that requires the chain rule. So it's like first times the derivative of the second. And then plus the second. Oh wait, there's a mistake here. Sorry. Oh no, there's not. Oh, sorry, there's not a mistake. We are locked in, but I think Malik is locked out. He has not shown up, you see? So this is first times the derivative of the second. So derivative of the second, I dropped down the half, subtracted 1, just incorrectly, I should say. I thought something was off. And then derivative of the inside plus the second. And then derivative of the first is going to be 3x. Okay, Aeon, from here you can do this. We did this in class already and all that, but just you evaluate this at 2. Sub in a 2, you get your answer. Okay, all right, Adam 110. I gotta skip that. I'll do the next one, supplementary one, number 11 on page 102. Number 11. Oh, 11G, sorry. Okay, someone wanted 11G on page 102 of the supplementary textbook? Sure. So for this one here, for 11G, page 102, I think it's this one. I don't know who am I talking to here. Okay, they want the derivative of this one. This is dy dx. For dy dx here, you got to go ahead and do the power rule. So drop down the 2, and we're here. And then the derivative of the inside kicks in. So when you take your power rule, you drop down the 2, subtract 1. This is not just an x, it's a whole new function. So when you go to take the derivative of the inside, right, I've dropped down this exponent, subtracted 1, you have to take the derivative of the inside, in which case you get f prime at x squared. But then again, this was not just an x, it was an x squared, so the chain rule will kick in a second time and give you 2x. So for this one, this is dy dx is 4x f of x squared, f prime of x squared. Is that okay? Whoever had asked that one, 11G, WE, I think it was. Not sure. Wrestling fan, perhaps. Arj, what textbook is this from? 7B 110. Is that the class textbook? Can you do page... Oh, I'm on to the class textbook now? Okay. I'll move to the class textbook if you guys want. Class, sure. It seems like everyone wants the class textbook. Arj. SC says 1107C, please. Where is this from? All right. Too slow. 1107B. Oh, class, okay. Okay, page 110, Arj wants 7B. Okay. Oh, you know, this one here... So for this one here, they're asking for the derivative. We kind of talked about this. I know I did mention this with one of my classes, but they're asking for the dy dx when x is 4. But I don't have the function in terms of x. So what you have to do for this one is to find your dy dx. For 7b, I'm going to have to take the derivative of y with respect to u and multiply that by the derivative of u with respect to x to get there. So you kind of have to do this step first. So off to the side of your page, you can calculate du dx, which du dx is going to be 110. I can pop the coefficient out and then take the derivative of the inside, which is just this. So like du dx is going to be equal to, I guess we could write that as 1 over 20 x to the minus 1/2 plus 1 over 10. That's your du dx. So now I want to find dy dx, or dy du I should say. So I want to take the derivative of y with respect to u. That's this one right here. So to do that, I'll have to do the quotient rule. So I think I'll just put it right inside. So dy dx is going to equal, so this, I have to take the derivative with respect to u. So that means I'm going to have to do the quotient rule. So it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So this right here, this is your derivative of y with respect to u. and then you're multiplying by this value here. Cooked. Yeah. So it's here. Now they want you to evaluate this. Like the question's asking for dy dx when x is 4, right? So when x is 4, you know that u is equal to the root of x plus x over 10. So this will be 2 plus 4 over 10, which is 6 over 10, right? Which is 3/5. So you can kind of sub that in to here. So u is 3/5. So you have to dump that all in your equation. I won't continue this one. It's a little computational. But that's the idea. What some people did was they substituted in u as x directly into the function and evaluated it. Like, so they didn't have to do the chain rule on it. And x is 4 here. I'll let you guys finish this up, this one. But you'd have to calculate all of this. I can throw on the class notes. Did I put class notes for period? I'm pretty sure I put class notes for at least one class. Period 1, 2? Sure thing, Shams. I can't remember what class I thought I uploaded for both classes. Whatever class I uploaded it for, you know my favorite class then. Page 106, 8D. All right, Shams wanted this one. It's a good question here. Let's look at it. This is h at x. I hope your pillows never cold. Oh yes. If I put 8D on, oh, I see. Nice. Okay, so with this one here, so Shams wanted this one, and they want you to fully simplify. Let's go through it. So this is h prime at x is your first times the derivative of the second. Don't forget to take the derivative of the inside, plus the second times the derivative of the first. And then we can continue. So this is h prime at x is GCF out what you can. So I have, I have a 2 and a 3 here. And a 3 here. So I can GCF out a 3. I can also factor out an x squared. And I can also factor out a single 3x minus 5. So what am I left with? I'm going to be left with a 2. I'll be left with no 3x minus 5s, no 2s. No 3x minus 5s, no 3s. And I took out an x squared. I'll be left with a single x. So this will be 2x. And then I'm left with here a single 3x minus 5. So h prime at x is 3x squared, 3x minus 5 times 5x minus 5. And Shams, you might have forgotten to GCF out the 5 here. There's a common factor of 5 here. So h prime of x is 15x squared, 3x minus 5, x minus 1. Why didn't you take the derivative of the inside of 3x squared? So Shams, with this one here, if you follow its first, times the derivative of the second. So I dropped down the 2, subtracted 1, and took the derivative of the inside, which is 3. Plus the second, so I wrote it down just as it is. When you go to take the derivative of the first, there is no inside, because if I drop the 3 and subtract 1, that's it. Like, I don't have an x in there, so that's done. Okay. Question 11223C, class textbook, sure. Page 11223C. Okay, I can post class notes for that. I guess. Maybe. Sure, yeah, I can. You have to find one for me, but yeah, I can take that up. For 23C here, who was asking this? Okay, here we go, 23C. So they ask you in this function, they give you the function f at x is this root of a quadratic, and they want you to find when it's not differentiable. You first have to take your derivative. So f prime at x, you go ahead and take your derivative of this thing. Subtract 1. Then take the derivative of the inside is 2x minus 7. So my derivative for this question becomes 2x minus 7 over 2 to the square root of x squared minus 7x plus 6. So that becomes my derivative, my first derivative, f prime. And they're asking where is it not differentiable? It's not differentiable when the bottom, essentially this is not differentiable when 7x squared minus 7x plus 6 when it's less than 0. So whenever that's less than 0, it's not differentiable. So I just have to figure out where that happens. But this is a quadratic. So this factors into x minus 6, x minus 1. So if I go to graph this thing, this opens upwards. It has roots at 1 and 6. This looks something like this. And I want to know when is this strictly less than 0. That's this right here. From here to here, these are the roots at 1 and 6. So therefore, this function is not differentiable. Like this is not differentiable when x is inside the interval 1 to 6. So you could say like on the interval 1 to 6, notice I have open brackets on both the endpoints. So between 1 and 6, like greater than 1 and less than, strictly less than 6, you'd be taking the root of a negative number for your first derivative. So it's not differentiable there. Is this good? Okay. Sure, Hamat. Number 5, finding equations of tangent lines. So for this one, Hamat, they want you to find the equations of all horizontal tangents to the curve. So horizontal tangent means that the first derivative is 0. So I take my first derivative, I get 3x squared plus 8x minus 3, and you're setting this equal to 0. because you want to know when the first derivative is 0. So then you can factor this quadratic quickly, like doing charting, decomposition, whatever you want to factor this. So this comes out to be here. So factoring this quadratic, I get 3x minus 1 times x plus 3 equals 0. And that's going to give you two values. It's going to give you a third and minus 3 for the x values. So, okay, give me a second. So that becomes the x values. They want the equations. So, I mean, I'll let you, well, it won't take long. So sub this in here for each equation. So for this one here, I want to find the y value. So this is going to be like f at a third is going to be like 1/3 cubed minus 4 times a third squared. And I completely ran out of room, so I've got to do this. I'll do this here. Sorry guys, here, I'll just move it over here. It's like getting caught. So f at a third, you have to find the y coordinate. So I have to sub this back in here. So this will be 1/3 cubed plus 4 times 1/3 squared minus 3 times 1/3 plus 1. So this is 1/27 plus 4/9 minus 1 plus 1. So I'll let you do the other one, Hamat, but this is like 12/27 is 13/27. So like when at x is minus a third, you have a point of tangency that creates a horizontal tangent at this value here. So since it's a horizontal tangent, the equation should be y equals 13/27 for this one. And then the other one's the same. I believe that's the answer. It's, I guess, a little bit different. Because it's a horizontal tangent, there's no slope, right? So it's just going to be the y value. Sure. Okay, so I kind of lost track here. 110, number 10 from the class textbook. And Eric, I'll get to the... Actually, I got the worksheet right here. You want number 6 from the same worksheet. Sure, I can do that. Number 6. Same worksheet. Number 6. So with this one here, sorry guys, with this one here, they want the tangent perpendicular. So if you're going to answer this one here, I need to find the slope of this line. Well, the slope of this line is like this. X is 1/2 x plus 3. So I want the perpendicular slope. So perpendicular slope is your negative reciprocal, which is -2. So I need to find all horizontal tangents that have a slope of -2. So I'm going to go ahead and take my derivative here. So this is 2x cubed plus 4x squared minus 2x minus 6. And you're setting this equal to minus 2, right? So again, the deal here is like, what is the slope of this line? It's a half. I want a slope that's perpendicular, so take the negative reciprocal to make it perpendicular. Then take your derivative and set it equal to what you want. And then you're just solving this. So if I solve this, you get 2x cubed plus 4x squared minus 2x minus 4 is 0 when I bring the negative 2 to the other side. And then you can factor out a 2x squared. You get x plus 2. Factor out a minus sign, or minus 2 here. I'll get an x plus 2 a second time, which is what I want. And then you can factor this by charting. So this becomes x plus 2 times 2x squared minus 2 is 0. And I can factor the 2 out. If you want to fully factor it, you can. It doesn't matter. And I'm here. And the x values, Eric, are negative 2 or plus or minus 1. Right? So a similar type of problem that we've done. Sure, Arj. Oh, wait. Ion wanted 1D. I can do that too. Is this good? So took the negative reciprocal. It's negative 2. I set it equal to the derivative of the function, brought it over, factor by grouping, and I got my roots here. If anything's going too fast, you can always rewatch. Like when this is done, it'll save it, so you can watch it if you want to like review anything. Okay. Ion wanted 1D from the tangent equation worksheet. Sure. Just because I got it right here, 1D. I can do that right on this sheet. Determine the equation of the tangent line of the curve at the value. Okay, so for 1D here, y is going to be, I'd write this in exponential form. Makes it easier to see. And they want dy dx when x is 1. So I'm going to take my derivative, which is negative 10x to the minus 3, minus 1/2 x to the minus 3/2. You don't have to worry about simplifying it or anything like that because they just want a number. They want the value when x is 1. So I'm going to let x be 1 here, which will give me negative 10 minus 1/2, which is negative 21 over 2. That would be my slope. That would be my slope. And they want the tangent equation. So then we have y equals minus 21 over 2x plus my y-intercept. And I need a point here. So the only x value I have, I did this at 1. So I'm going to have to sub a 1 into this equation to get the corresponding y value. So if you sub a 1 into here, you're going to get 6. So the point is 1/6, like the point of tangency is 1/6. So I'm in a situation where I have my equation, Ion, and I'm going to sub this point in. So it's going to be 6 is minus 21 over 2 plus b. And I can solve for my y-intercept here. So the y-intercept is 6 plus 21 over 2, which is 12 plus 21 is 33 over 2. Is your b value with this one. So I know it's all sort of crammed up. I don't know if you can see it. But the answer should be y equals minus 21 over 2x plus 33 over 2. They probably multiplied across by 2. And then brought everything to one side. Something like that for the answer. Is that good? Is that good, Ion? Good, it's light. This is good. It's probably the same answer. I don't have the answer on me to double check it, but I'm sure they manipulated it to get to it. Okay, anything else? Yeah, I don't have it loaded, the answer sheet. So unless you want to type it up, you can type it up. Feel free to type it up. Put it in the chat. I don't know if I missed 15, please, from 110.15. Sure. Page 110, number 15. Yeah, that's the same answer. Like, if you distribute it, bring everything to one side and get rid of the fractions, for sure. Arj wants 110.15, and then Yusuf wants one. Okay, class textbook. I'll just write that down since I've got the class textbook out. 106, number 10. All right. Okay, 110, number 15. Oh, yeah. I'm surprised no one asked this. So for this question here, they give you this function. Okay, 110 number 7c, and then number 10, please. Oh, and number 10. 110 number 10. Okay, volts. Okay, so Arj, with this question here for 15, they give you this kind of function, and it looks something like, it's kind of like looking like this. Got something along those lines here. And they want you in the first question to say, determine the slope of the tangent at the point where the graph crosses the x-axis. So what they're asking you to find is they're asking you to find the slope of the tangent right here. So, but like the problem is that's where I cross the x-axis. So I first have to find out like where does this function cross the x-axis? Well, this function crosses the x-axis when f at x is 0. So I set f at x equal to 0. And then you bring this to one side, right? So you're looking to solve for x here. The best way to do this, I would say, is to multiply both sides of the equation by x to the third. So you see, if I multiply both sides of the equation by x to the third, it makes things quite nice here. Because this ends up being 5x, right? Because x to the 2/3 times x to the 1/3 is just x. This ends up being 2x squared. You see? So if I bring this to one side, it's 5x minus 2x squared is 0. I can factor the x out. I get 5 minus 2x is 0. And that's going to give you two values. One is 0 and the other is 5/2. These are the two times where your function touches the x-axis. But at 0, that's no good. The derivative's undefined there. That's like a point, right? That's a peak. We had talked about peaks are non-differentiable. Exactly. So the derivative that you're interested in, what you're interested in, Arj, is at the 5/2. So that means I need to find the slope at 5/2. So step number 1 is to take your derivative of your function. I'm gonna take the derivative. Actually, I'll just make this smaller here. Okay. So I'll take the derivative of this. If I take the derivative of this, it's going to be equal to, sorry, let me just grab this. It's going to be 2 times 5/3 x to the 2/3 minus 5 times 2/3 x to the negative 1/3 when I take my derivative. So this becomes f prime at x. I want to find, so as we were talking about Arj, I want to find this at the value I found at 5/2, right? Like I want to find the slope of the tangent line when I cross the x-axis. So we did all this work to find where I do cross the x-axis. So now I can evaluate this at 5/2. This will be 2 times 5/3 times 5/2 to the 2/3 minus 5 times 2/3 times 5/2 to the minus 1/3. And whatever this is, when you punch in your calculator, it should break it down to like something decent, and that would be your answer. Okay, that was 15. In B, they ask you to determine the value of A shown in the graph. The only thing they're asking you for in part B is they say shown in the graph. They're just highlighting, if you don't have your textbook, they're just saying what is this value here? Well, that's when their slope is 0. So the only thing that they're asking me to do in part B is to take your derivative of your function. So in this case here, f prime at x, you take your derivative of your function, which I guess we've already done, but I'll just do it again. Minus 1/3. And they're just asking for part B, they're just asking when is the slope 0. So you're just solving this equation now. I would yet again do the similar trick. I would multiply both sides of this equation by x to the third, like just to get rid of these negative exponents. I would multiply both sides of the equation by x to the power of 1/3. I would take this and multiply by x to the 1/3. So if you do that, the left-hand side is unchanged, but the right-hand side is considerably easier. This becomes 2 times 5/3. That'll just become an x minus 5 times 2/3, and that'll completely go away. So it simplifies quite a lot by multiplying it across by x to the third. And then you can bring it to one side here. I might as well here, I'll just leave it like this for now, I guess. And we can solve for x. So this becomes 10/3 is equal to 10/3 x. So I'm getting x is 1 for that. The x value is 1. So in this case they called it the a value, but it's I just let it be x. So a is 1, and then whatever f at 1 is. Yes, thank you, sire. Captain. All right, did it. Wait, we have a bunch here, right? This one's check. Then we got, 110. I'll do 7C and 10. 7C and 10 since I'm on the same page. So page 110, number 7C and 10. Then I'll go back and do that other question. 7C, you guys can disregard 7C. I've answered it a couple of times. Something similar, like I did 7B above. You don't have to worry about it for the test. Oh, thanks, Yusuf. Okay, that one's done. That's done. 7C, don't worry about it. And then I've got 110, number 10 still left here. 110, number 10. So page 110, number 10 has multiple questions on it. So don't know what you're talking about there. Volts. Not sure what that is. Okay, we've got Jack wants 29-113 of class textbook. Sure. 29-113. Oh, 10A. Determine the values of x where the derivative is. Sure. So for 10A, you just got the question. I was about to move on. All right, so for 10A here, they just want, again, they're asking for horizontal tangents. So you take your derivative and set it equal to 0. So take your derivative, drop down the 5, subtract 1, derivative the inside using the chain rule, and you set this equal to 0. So this becomes 10x, x squared minus 4 to the power of 4. So when is this equal to 0? Well, this is going to equal 0 when x is 0 or x is plus or minus 2. So that's it. Is that good? No problem. Okay, I had Jack wanted page 113, number 29. And Shams, I'll go back and do that other one. Page 113, number 29. So for this one, they give you a function. F at x is ax squared plus bx plus c. And they give you a bunch of information. They tell you have x intercepts, like, or roots, however you want to word it. They essentially just say you have roots at 0 and 8. And then they say that you have a tangent. They tell you that f prime at 2 is 16. They say that you have a tangent line that has a slope of 16 at x equals 2 on the function. So you use all this to your advantage to find the values of a, b, and c. So because these are roots, I know that if I let x be 0, the f at, like, if that's a root, I know that f at 0 is 0. And if this is a root, I know f at 8 is 0. So therefore I have a times 0 squared plus b times 0 plus c. So this implies that c is 0. And then using this here, I can do it again. So I know that 0 is going to equal the function at 8 this time. So a squared plus b times 8 plus I just found out that c is 0, so I can change this to a 0. So that means that 0 equals 64a plus 8b. And if I divide across by 8, that means that 0 equals 8a plus b. So I've got like a relationship between a and b here for 113, number 29. I have not used this piece of information yet. So I'm going to go ahead and take my derivative. So f prime at x is 2ax plus b. And therefore I know if I let a be 2 for my derivative, it's going to equal 16. So therefore 16 is 4a plus b. So you see for this question, you have two equations and two unknowns. And I can use it to solve. I can use it to solve this equation. So I guess I'll just solve this. So I can subtract these up. I get negative 16 is 4a, or a is negative 4. And if a is negative 4, you can sub it into either equation and solve for b. b is negative 8 times a, which is negative 8 times negative 4. And b is 32. So to like summarize this, your a value is negative 4, your b value is 32, and your c value, which you've already found, is 0. No problem. Okay, Shams wanted 106, number 10. So this is 1 plus x cubed squared, and y is 2x to the 6. So for page 106, number 10, they give you two different functions, and they want you to find the values of x where they have the same slope. So they're essentially asking you to find the values of x where their first derivatives are the same, if it exists at all. So I'm going to go ahead and calculate y prime here. Right, that's like my first derivative. So this would be 6x squared, 1 plus x cubed. That's my y prime for this function. And then I'm going to do it for the second function, in which case I get 12x to the 5th. And I want to know, is there ever a situation where these slopes are going to be the same? So the only thing I do is set these two equal. And see if a solution exists for this. So this will be 6x squared plus 6x to the fifth equals 12x to the fifth. If I bring everything to one side, I get 6x to the fifth minus 6x squared. And you can factor out a 6x squared. I get x cubed minus 1. So this factors, you get 6x squared, and then you got your difference of cubes formula. And you can solve this equation just like your functions class now. This is going to give you complex roots. It's no good. So there's only two values that this will yield, Shams. You're going to get x is 0 or 1. Someone had asked something. Arj asked 7b and someone else asked 7c. I won't put that on the test. You're welcome. Yusuf, oh sure, got it. Okay, yeah, you can't divide it out. I mean, I don't know, like as a simplified reason as to why, if someone asks you to solve this equation, someone says, for what values of x is the following equation true? If you were to divide across by x on both sides of the equation, you'd say x equals 1 and you'd be done. But the problem with that is when you divide across by x, you're assuming that you're not dividing by 0. So in this case, I'm assuming that x can't be 0. But then that's one of the solutions. So by dividing across by x and reducing it to become this equation, you're omitting the existence of, you're saying 0 can't happen. But 0 can happen. It can happen right here. So if you're here, let's say you're here, and you divide across by x squared, you're omitting one of the roots. Because the only way you can divide across by x squared is if you assume that x can't be 0. So by doing that, you missed a root. So this is the reason. Yeah, no problem. I've kind of lost track of where am I at here? Have I answered all the questions? Oh, sorry. Yeah, number 9 on page 110. Sure, 9. Page 110, number 9. 110, number 9. Locked in. Oh, for what values of x does the curve have a slope? Sure. So these are good practice questions here. You got minus x cubed plus 6x squared. So for 110, number 9, it's just some quick little questions. You don't have to do the graphing portion of it, though. But they ask you for what values of x do you have a slope of minus 12? So you go ahead and take your derivative. So dy dx is minus 3x squared plus 12x. And they're asking when is it minus 12? You set this equal to minus 12. Then divide across by minus 3. So, right, so what I did was I took my derivative here, and I set it equal to the slope they asked, and I brought this over. Now to solve this here, you can check your discriminant to see what you get. I get b squared minus 4ac, and the discriminant here is 16 plus 16 is 32. So to solve this, I'm going to have to do the quadratic equation. So this will be x equals negative b, so 4 plus or minus the root of 32 over 2 times 1. So this will be 4 plus or minus 4 root 2 over 2. So I end up getting 2 plus or minus 2 root 2 for that one, Malik. I'm not sure if 9 was assigned, but it's a fine question. I'm glad Malik asked it, because like we had to use the quadratic equation here, and I had to simplify it a bit. 16 times 2 and then perfect square. So there's 9, and then like this for the next one, it's the same idea. No, I can't do that, sorry. I cannot. Anything else? You guys are probably getting tired. Probably time for bed. But there's tons to practice in the book if you want to try more. Like, you can go through your class textbook or the red book. Did you do a 7A DB? 7A and DB. 7A and B. Yeah. From where? There's so many different number 7s. Page 110, number 7. You guys don't have to do 7A or B. It's fine. I think I assigned A and B. 7C is fine, I guess. Like, we were practicing this today, and there's your dy dx. I was only talking about 7A and B. Like, 7C we've done. Like, in class. I did it today, like, messing around with stuff like this. But 7A and B are just a bit weird because of the substitution. But 7C is fine. It's a normal question. They just want the derivative of y with respect to x when x is 4. So this is f prime at, this is going to be 16 plus 9. This is going to be f prime at 5 times a half times 25 to the minus a half times 2 times 4. But in the question, they tell me that this is negative 2. So I'm just subbing all this in. This will be 1 over 5. And that'll be 8. So negative 8/5 for that one. Sure, 23. Um... 10, okay, 1 second. 7C is doable. Thank you. Sorry, number 23. Did I just do 23? Oh, what the heck is 23? 23. Oh, 112. Oh, I got it. Okay. No, I did 23C. I have not done 23A. So for 23A, they want to know when is it not differentiable? Well, step 1 is to go ahead and take the derivative. Right? So pop that to the top and do your power rule on this. So f prime at x is going to be negative 3, 4x squared minus x to the negative 2 times 8x minus 1. So now f prime at x is going to equal negative 3 times 8x minus 1 over 4x squared minus x squared. So when is this not differentiable? This is not differentiable when this is not differentiable when the bottom is 0. Well, when is the bottom 0? The bottom is 0 when 4x squared minus x is 0. Which if I factor out the x, it'll look like this. And that's at two numbers. When x is 0 or a quarter, these are points where the function is not differentiable. Hello. Does that make sense? Right? So I just took my derivative normally. Okay, when is it? It's pretty much like if you were to compare it to your functions class that you guys took, it's pretty much asking the same question. Once you take your derivative, you're really just asking where's the function undefined, or what is the domain of the function. You're kicking that out. No, not always, because you might miss some values. Like it just so happened that wherever the original function is undefined, it's not differentiable, so it didn't generate any new points of non-differentiability. But there's lots of functions where you take its derivative and it generates spots that are not differentiable. Yes, 1 over 4 is 0.25. Like 1 over 4 is 0.25, so it's okay. No, he's not. He's locked. Arj is locked in. I have faith. Sure, 1021H. Lock in. 1021H. 102. Oh, that's from supplementary textbook. So 102 number, what was it here? Sorry guys, we had to kick our joke. 1021H. Y is 4 over the square root of 9 minus x squared. So for this one here, they want you to take your derivative and we have to simplify this. So this will be y is 4, 9 minus x squared to the minus 1/2. And then we're going to go ahead and take our derivative of this. So this will be dy dx is going to be 4 times minus 1/2, 9 minus x squared to the minus 3/2. And then the derivative inside is minus 2x. Right, so pop this to the top here. I did the power rule. I dropped this down, subtract 1, which is right. And then and then go ahead and subtract 1. You get minus 3/2. Derivative inside is minus 2x. So for this right here, we've got dy dx. I want to evaluate this when x is what? What is going on? Please stop. All right, I want to evaluate this. Yeah, maybe. I want to evaluate this when x is what? Thanks for the coffee. I want to evaluate this when x is 2. Oh, is it just simplifying this? No, definitely not. So I don't know where I am with this, but this becomes 4x over 9 minus x squared to the 3/2. I think that's it for 1H, whoever asked it. Okay, yeah, I wasn't sure what to do with it. No, it's a good question. I wasn't sure how to simplify it anymore. Sure. For sure, for sure. Which question? And then, sir, can you take up number? Oh, I can't. Sorry, Eric. It's blocking your. Number 12, sure. All right, yeah, 1 second. Let me just get done 12 here. And then I think we should stop. If it's too late, you get just. And get all the weirdos showing up here, you know. So let's take a look here at 12. All right, here we are, here we are, here we are. Here we are. All right. Well, let's do this. Okay, so Eric, this one here is stop. All right, let me just get done 12 here. And then we'll stop it here. You guys are probably done. But, okay. So they give you a function y is 2 root x, and they want all possible points of tangent c. A tangent line is drawn from the point to the curve. Find all possible points of tangency. So, Eric, this is a good one. It's just like what we did from our older test, I think our first one. So you have a function. This is 2 root x. This is 2 root x. And you have a point -3 and 2. -3 and 2 is not on the function. It's like all the way over here. And they're asking you how many points of tangency exist between these two. Like, where would it be? So this point here would be the point x, 2 root x. Right? So remember we kind of did this on the last test. You're going to go ahead and calculate the slope of this line. Eric, are you with me on this so far? I feel like, do you see like I'm calculating the slope between this line here? So like changing your y over changing your x. But that also has to equal the derivative of the function. So y prime is 2 times 1/2 x to the minus 1/2. So y prime is 1 over the root of x. So this is 1 over the root of x. So you're kind of setting these equal and solving, I believe. So this is 2x minus 2 root x is x plus 3. Right? So this is number 12, guys. It's like the question where how many find all possible tangent equations that cross through the point. They're wording it a bit differently, but it's the same idea. I think you're only going to get one here, though. Let's just see what happens. So this ends up being, if I bring everything to one side, I get x minus 2 root x minus 3 is 0. So this will factor into the root of x minus 3 times the root of x plus 1. So it's going to give you two answers. The root of x is 3 or minus 1. But x is positive, so you can't have, like, you're not going to, it'll never yield a negative value. So if I square this, you're going to get x is 9. So the only point of tangency is going to be 9, and x is 9. And if x is 9, if I sub it into here, you're going to get 9 and 6. That's the only point of tangency I'm getting. Sketching? I like only sketching to help you figure out the graph. Okay, you're welcome. Is this okay? Daniel's saying, sir, before you leave, could you please post the solution? Oh yes. I'll post that. The proof can't you watch the video? There's the video of it. You got a video. If you don't mind just to watch that, probably. Okay, so Daniel says post a thing. And are there any other questions that we need, like last minute stuff? You got out of control, Arj. I had to ban you. 29 could be locked in. We don't know. Could be dialed up there. No. Oh. All right, guys. I think you'll be fine tomorrow. Please make sure you've done all the homework problems. I think you'll be fine. Know the please know the proofs, right? There's like, what is there? Power rule, product rule, and quotient rule. Know those proofs. Maybe do those first when you get to the test. Be able to take a derivative and simplify it. Take a derivative and evaluate it at a number. And if you've gone through all the homework and whatnot, should be okay. Remember the tangent equation stuff? Tangent equation worksheet. Yeah, all three. All three for sure. The solution posted for what? 29? What is this 29 people keep asking about? Did I answer 29? I don't know. What is 29? 29 was... I see no... Oh, this one? Oh. Well, you've got this video is saved. You can watch the video. Yeah, right here. It's right here. Yeah. This will save, and then you can watch it. You guys can relive why Arj got banned. I don't have the timestamp, but it is. I'm an hour and 21 minutes in. So at an hour and 21, this exact conversation will reduplicate. All right. Is there anything else? Are we okay? So study up, guys. Period 1, don't tell period 5-7 what's on the test. Sir, can you do 10 from the tangent equation worksheet? I feel like I've already done 10, but let me see. I did 10 in class. It's in the notes. I did it in class. 10. This has been done. I did it in both classes. It'll also be in the notes. I'll post it in the notes as well. Ayan, are you in my period 1 class? No, period 1's not telling you guys. They've had enough. But Ayan, I'll post this into the, there's a worksheet that's, we did this in class, so I'll have it with the solutions. Yes. No, I'm not, no. I'm not going to post this as a PDF, but I'll post the classwork. You can watch the video again, Maru. All right, that's it. Boom. Goodbye, Cheyenne. Okay. That's it, guys. So good luck tomorrow. I'm gonna see ya. I'm gonna go ahead and end the stream. This will regroup. It should be available for you if you want to watch it. You can watch it again. In the meantime, I'll quickly post notes from period 5-7. Yeah, no problem. It's not a problem at all. It's like very easy. And that's it. Okay. Have a good night, guys. Good luck tomorrow. No, you just have to know one proof. It's just one proof. Yeah, no problem. See ya.